Well, hello, Algebra 2 people. We are about to start a new unit, Unit 2, which is all about exponents, square roots, and complex numbers. This unit is really all going to be about developing tools that we will be using throughout the rest of the year. Tools that we're going to need to understand quadratic equations and quadratic functions and polynomials and all sorts of things as we move through the year. This is really going to be setting the foundation for several of those things. We're going to start in section 2.1, which is on page 3. And we're going to start with 2 days on laws of exponents. There are a total of 6 laws of exponents that we're going to get into over the next 2 days. And the first thing I want to do is take a look at that problem. Zoom in a little bit more. X squared times x cubed. Well, I think x squared times x cubed is really like saying, okay, x squared is x times x cubed is x times x times x. And if I multiply x times x times x times x times x, I don't get 5x, but rather I get x raised to the 5th. X squared times x to the 3rd gives us x to the 5th. There's a shortcut rule for doing this. When you multiply 2 variables together, what can you do to their powers? We're just going to add the powers because 2 plus 3 gives us 5. In general, if I have x to the a times x to the b, this is going to equal x to the a plus b. When we multiply variables with powers on them, we just add the powers. So, in letter a squared times a to the 7th, I'm not going to write them all out. I can just use my new law of exponents. I'm going to get a to the 2 plus 7. I'm going to get a to the 9th. In letter b, when we have numbers raised to powers, we're going to treat them just like they were variables. So you know what? This problem is like saying x cubed times x to the 4th. X cubed times x to the 4th would give you what? Hopefully you just added those powers and you would say x to the 7th. I'm going to do the same thing here. 2 to the 3rd times 2 to the 4th gives me 2, don't change that, to the 7th. However, now that we have 2 to the 7th, we should probably figure that out. So take a moment, go to your calculator. Let's get 2 to the 7th. If you type that in, that should give you 128. What's important is we're not multiplying like 2 times 2 and getting 4 to the anything. I'm treating the 2 because it has an exponent like a variable. I'm going to add the powers, and then I'm going to figure it out. Letter C. See what you can do in letter C. I think I'm going to multiply m to the 3rd times m to the 5th, and that's going to give me m to the 8th. The n to the 4th will just stay by itself, so m to the 8th times n to the 4th. In letter D, I actually don't need those parentheses there. This is really like saying 3 times m cubed times 2 times m to the 5th. I'm going to multiply the numbers, and I'm going to multiply the variables. When I multiply 3 times 2, I'll get 6. And when I multiply m to the 3rd times m to the 5th, we're going to get m to the 8th. That's it. Take a look at letter E. In letter E, what's the entire answer to letter E? I think we should get 10. Negative 5 times negative 2 is 10. M squared times m to the 4th gives us m to the 6th. Letter F, go do it. What's the number you're going to get out front? 3 times negative 8, negative 24. You're going to get m raised to what power? I think that's m to the 2 plus m by itself is just like m to the 1st, so m to the 3rd. And n raised to the what? I think we're going to get n to the 5 plus 2, n to the 7th. Negative 24, n to the 3rd, n to the 7th. That's our first law of exponents. When you multiply variables, you add the powers. Second law. X squared cubed is like saying x squared times x squared times x squared. Well, what is x squared times x squared times x squared? I think that's just going to give us, by our first law that says add the powers, we're going to get x to the 6th. So what do I do if I have a variable with a power raised to another power? What's the shortcut I can do to those two powers? We're just going to multiply them. And that's what our second law is going to say. X to the a raised to the b is going to equal x to the a times b. A variable to a power raised to another power, we can just multiply those powers together. Turn to page 4. And you can totally do letter A. What's the answer to letter A? Power to a power, we multiply them, we're going to get a to the 5 times 7, a to the 35th. In letter B, remember what I told you before about numbers with powers. We're going to treat it just like it was a variable with a power. So we're going to get 2 to the 3 times 2, 2 to the 6th. But then, of course, make sure you actually simplify that. So what is 2 to the 6th? I think that should give you 64. Letter C. By our order of operations, I should go do this problem first. And when I do x squared to the 5th, I'm going to get x to the, multiply the powers together, 2 times 5 gives us 10, x to the 10th. Now, you're going to multiply those variables, which means you need to add the powers together. This is going to give you x to the 2 plus 10, x to the 12th. So some of these will take a step or two of work. See what you can do in letter D. Let's see, so I'm going to do x to the 4th to the 6th. I'm going to get x to the 24th, and then x to the 1st times x to the 24th should give me x to the 25th. Third law of exponents. xy squared, I think means xy times xy. Or, how about just x times y times x times y, which is really x squared, y squared. All I'm trying to show you here is that if we have a product involving variables raised to a power, we are allowed to distribute the power. xy to the a is going to equal x to the a, y to the a. Get that one copied down. Actually, and when you're done with that, go do letter A as well. I think this is just going to give us x to the 3rd, y to the 3rd. What I don't want you to get confused by is how this relates to foiling. This is not foiling. I would do that if I had like an x plus y squared, but just x times y squared. No, we just distribute our power. In letter B, well, I'm going to go and I'm going to distribute my power there. X squared to the 4th, by law number 2, means I should be multiplying those powers, and I'm going to get x, hold on, let me move this up, sorry about that. I'm going to get x to the 8th. I'm also going to get y to the 1st, to the 4th. I'm going to multiply those, and I'm going to get y to the 4th. X to the 8th, y to the 4th. Go do letter C, and tell me it's going to become x to the what? X to the 12th. And y to the what? Y to the 20th. Next, we have some numbers thrown in here. I need to distribute the 2, and I need to distribute it to both of these pieces here. I need to square the 5, so I'm going to say 5 squared, and I need to square the a cubed, so I'm going to say a to the 6th. Well, 5 squared is just 25, so I'm going to say this is 25a to the 6th. Doing it in steps is particularly important when we get to something like letter E. In letter E, I'm going to do -2 in parentheses squared, and the parentheses are going to make a difference. -2 in parentheses squared. Then we'll get a to the 4th and b to the 6th. What is -2 in parentheses squared? This means -2 times -2, that means +4. And if you were to go to the calculator for that, make sure you're doing it in parentheses, because without the parentheses, it'll tell you -4, which is wrong. Letter F. I think, you know what? See what you can do in F. When you're done, tell me what the power of A is and tell me what the power of B is. I'm going to distribute my 4th power, so AB to the 5th times A to the 8th, B to the 12th. And then I'm going to multiply them, which means add the powers. A to the 1st times A to the 8th, you should have told me A to the 9th. B to the 5th times B to the 12th, you should tell me B to the 17th. A to the 9th, B to the 17th. In letter G, we're going to distribute the powers. We're going to get 6 squared, x to the 4th, times 3 cubed, x to the 6th, y to the 3rd. We need to figure out these numbers raised to our powers. So get a number for those, and then do the multiplication problem. See what you can do in letter G. Well, this is 36 x to the 4th times 27 x to the 6th, y to the 3rd. 36 times 27, you're going to want a calculator for that. But that should be 972. X to the 4 plus 6 is 10, x to the 10th, y to the 3rd. I want to see if you can do h. H is about as tricky as they're going to get for right now. Remember, when you do -4 squared, make sure it's -4 in parentheses squared. See what you can do in h, and then I'm going to ask you for the number up front, the power on the x, and the power on the y. Okay, so -4 squared, x to the 6th, y to the 4th, times -3 cubed, x to the 3rd, y to the 9th. Well, -4 squared is 16, 16x to the 6th, y to the 4th, times -3 cubed is -27, x to the 3rd, y to the 9th. 16 times -27 is -432. X to the, okay, add those powers on the x, so 6 plus 3 gives me 9. Y to the 4 plus 9 gives me 13. -432, x to the 9th, y to the 13th. Fourth law of exponents. If we have the division problem, x to the 5th divided by x squared, this means x times x times x times x times x over x times x. What am I allowed to do with some of these x's? I think we can do some canceling here. I think I can cancel an x from the top and an x from the bottom. an x from the top and x from the bottom, I think my answer is just going to be x times x times x. I think it's just going to be x to the third. X to the fifth over x squared is just x to the third. However, if I have x squared over x to the fifth, this is x times x over x times x times x times x times x. I can still cancel two x's there. I'm left with x to the third, but I'm left with x to the third in the denominator of a fraction. My answer here is going to be 1 over x to the third. First question for you. In both of these examples, how am I taking 5 and 2 and getting 3? I think that's an obvious question. We're just subtracting. 5 minus 2 gives me 3. 5 minus 2 gives me 3. It's just a matter, though, of knowing if my answer is just going to be that or if it's going to end up in the bottom of a fraction. What would cause me to put my answer in the bottom of a fraction? I think in the second example, because the power was higher in the denominator, when I subtract, my answer will go in the denominator. Let me try to summarize this. X to the a over x to the b is going to equal x to the a minus b, as long as that numerator, the power in the numerator is greater than the power in the denominator. I'm also going to say x to the a over x to the b equals 1 over x to the b minus a, which will be what I do if the power in the denominator is bigger, if b is greater than a. It might be easier to think about it like this. All we're going to do is subtract the powers, the bigger number minus the smaller number. Subtract the powers. We're going to do the bigger number minus the smaller number. When we're done, we're going to put the answer wherever the bigger power was, either in the top of a fraction or in the bottom of our fraction. Put the answer where the bigger power was. I'll pause this for a moment so you can get that copied down. So let's take a look at a couple. In letter A to the 10th over a to the 7th, I'm going to subtract and I'm going to get a to the third. Since the 10 was bigger, I'm going to put my answer in the numerator of a fraction, like over 1, but I don't have to say the over 1. I'm just going to say a to the third, and that's my answer. Letter B, 2 to the 5th over 2 to the 3rd. Remember what I told you about numbers with exponents. We treat them just like variables with exponents. So I'm going to get b to the 5 minus 3, b to the second. I don't know why I said b. Sorry about that. I'm going to get 2. 2 to the 5th over 2 to the 3rd is 2 to the second, which will just give me 4. In letter C, well, the number in the bottom is bigger. I'm going to do 14 minus 8. I'm going to get x to the 4th. But because the x was bigger in the denominator, we're going to stick our answer in the denominator. And I'm going to say 1 over x to the 4th. By the way, I know you talked about negative exponents in Algebra 1. We're not going to deal with those today. We'll deal with those tomorrow. But I don't want you to say something like x to the negative 4 for an answer here. Let's make it 1 over x to the 4th. In letter D, I've got two variables to deal with. As for the m's, I'm going to do 8 minus 5, and I'm going to get m to the 3rd. Should the answer go on the top or on the bottom? Because the 8 was higher, we're going to put our answer on the bottom. I'm going to say m to the 3rd in the denominator. As for the n's, we're going to get n to the, 7 minus 2 is n to the 5th, top or bottom? Well, because the 7 was bigger, it's going to go on the bottom, n to the 5th. You're not really allowed, though, to have a fraction with nothing in the numerator. So let's just stick a 1 in the numerator. Let's make this 1 over m to the third, n to the fifth. Try letter E. And when you're done, I'm going to ask you what you have in the numerator and what you have in the denominator. So first of all, the 4 and the 10, I'm not going to subtract those because they're not exponents. I'm going to treat this like the fraction 4/10, and I'm going to simplify that fraction by just dividing the top and the bottom by 2. I'm going to get 2 on the top, 5 on the bottom. Now, as for the x's, x to the third over x squared, we're going to subtract the powers. 3 minus 2 gives us 1, so x to the first on the top. For the y's, 17 minus 10 is 7, y to the 7th, and that's going to go on the bottom because that's where I have the bigger power. See what you can do in f. You first need to distribute your exponents, and then you'll start doing this division rule. Try letter F, and again, when you're done, you're going to tell me what's in the top and what's in the bottom. So we're going to get 2 to the third, x to the 15th, y to the 18th, over 4 squared, x to the 6th, y to the 18th. Oh, that's kind of interesting. This is really just 8, x to the 15th, y to the 18th, over 16, x to the 6th, y to the 18th. I think those y's totally cancel. They're gone. 8 over 16, you can simplify that to 1 over 2. X to the 15th over x to the 6th, I think that's x to the 9th. No, you don't need the 1 there, so we could just say x to the 9th over 2. Okay, 2 more examples of this. And these really are as tough as they're going to get for right now. Letter G, see what you can do and either get down to an answer, or if you can't, once you get to a step where you're not sure how to go on, push continue, and I'll show you my work. So I'm going to first distribute those powers, ab to the third, c to the fourth, times, well, you know what, because it's just a positive number raised to a power, I'm just going to go do it. I'm going to say 25, a to the fourth, b to the sixth. The denominator is 16, 2 to the fourth, a to the fourth, c to the 24th. I'm now going to multiply. On the top, I get a 25, a to the, okay, add the powers. A to the first times a to the fourth gives me a to the fifth. B, add those powers. B to the third times b to the sixth gives me b to the 3 plus 6 is 9. And a c to the fourth. In the bottom, 16, a to the fourth, c to the 24th. Okay, well, I can't do anything with the 25 and the 16, so I'll just say 25 over 16. The a's, I think, will give me an a on the top. I've got a b to the 9th. And the c's will give me a c to the 20th on the bottom because I'm subtracting those exponents. 24 minus 4 gives me 20. Last one, and here I think I am going to get you started. Well, last one in this section. There will be another video you're going to watch today as well. I'm going to start by distributing the powers, and I'm going to get negative 5 in parentheses squared. X to the 6th, y to the 8th. Times negative 3 cubed. X to the 12th, y to the 6th, over, that's all I feel like doing. See if you can finish, and again, either get down to an answer, or once you find yourself getting a little confused, push continue, and I'll show you the rest of my work. So the bottom, I'm just going to say is 100, because this is already a positive number. I can handle that. x to the second, y to the 10th. So up top, I have a 25, x to the 6th, y to the 8th, times negative 27, x to the 12th, y to the 6th. Denominator is 100, x squared, y to the 10th. Well, I should multiply those things. 25 times negative 27 is negative 675. X to the 6th times x to the 12th, when you multiply, you add the powers, so x to the 18th. Y to the 8th times y to the 6th is y to the, add those powers, you're going to get y to the 14th. All over 100. X squared, y to the 10th. Now we're going to simplify. Negative 675 over 100 is negative 27 over 4. With the x's, x to the 18th over x squared, we're going to subtract the powers, because that's what we do when we divide variables, and we're going to get x to the 18 minus 2 is 16 on the top. As for the y's, y to the 14th over y to the 10th, again, we're going to subtract the powers. 14 minus 10 is 4, which will go on the top, because the 14 have the bigger power. Our answer here is negative 27, x to the 16th, y to the 4th, over 4. I think this is about as tricky as they're going to get for right now. In the next video, you're going to see two little variations, no new rules, just two variations on things. Oh, hold on.
Please excuse the interruption. This is a reminder for NHS members that there is a meeting tomorrow morning at 8
Well, as I was saying, I think this is about as tricky. Oh my gosh, and they're still talking.
Have a happy Thanksgiving.
Oh, good. Yes, I'm filming this on the Tuesday before Thanksgiving. I don't know what I was saying. This is about as tricky as they're going to get for now. You're going to see two more variations in the next video. More with that later. I think that's all I've got for right now.